Hey guys, it's Simon and welcome back to the LibGDX RPG tutorial series, in the last part actually of that series. And in that part we are going to cover the last important topic when it comes to Box2D, which is special contact events and how to react, for example, when the player is colliding or when he's moving over a so-called, I call it a trigger, so a specific area, or gets in contact with something. Also, you will learn and see how you can disable certain contact events in an easy way. And yeah, that's it. And the example that we are going to use is the one from the GitHub repository. So there is a trap in the middle of the map, and when you walk over it, the player gets damage and slowly regenerates then the hit points. We don't implement the damage part because we don't have the components for that we did not implement together, and it's not really relevant here. What we are going to implement is the reaction that when the player enters a specific trigger area, that the trigger is then executed, and also how you can link the trigger logic between Tiled and your game. This is what we are going to look at. And what I did in between the last part and this part is that I added the trap assets. So under assets raw, there is the trap with two graphics, idle down, idle up. So initially the trap will look like this. So there are no spikes. And once we are run inside this trap, then we play the animation for a short period. So we show the spikes and then we release them. And also we play a little sound effect. So this is what we are going to implement together in this part. So first of all, what do we need to do? So the way I solve that, or I usually solve that in my games, is that I introduce a new layer in Tiled, which I call a trigger. And in this trigger object layer, you can then place specific objects. In this part, we are just going to support rectangle objects again. So for example, let's place here the rectangle, resize it to have this specific tile here. And since that will be a physics body in the end and also ends up in our method where we pass map objects from tile to physics bodies, we also give it here our sensor property and make this specific trigger area a sensor so that it doesn't block the player from moving inside. And again, the sensor then can still react to when a contact is happening, so when the player walks inside it, but it doesn't block the player from anything. And also we are going to use a name, let's call that trap trigger. And that name here, first of all, has the benefit that in Tiled you already see what kind of trigger that is with a specific name, because we give this object a name. And also in our code base, this name will then be used to identify the logic that should be executed and then run the specific trap trigger logic. Okay, and additionally, we also want to have here something visual, and that would be an object. As mentioned, I created this trap object in between the last part and this part, and that one we are going to place exactly on that trigger area. And one thing to note here, so this trap here, let me show it to you in this view here. It's simply a game object with an idle animation, the object's atlas, and a set value of 0. We didn't use the set value so far. We pass it already in our logic, and now we use it. So the trap has a set value of 0. The default value is 1. And with a set value of 0, the trap always remains in the background. So even when the player walks over it, the trap still remains behind the player. This is what we want, and that is why the set value is set to 0 here for this object. Yeah, first of all, let's quickly start the game and see if we can see the trap. Looks good. So we can already see here the trap, and we can walk over it. So nothing happens currently with our trigger layer. But yeah, the object itself is already displayed, which is good. Good, then the next thing that we need to do is similar to what we did already in the past with loading objects and loading tiles and so on. We need to go to our TiledService, and there we will have a new consumer. In that specific case, it's a P consumer, so it has two values. It takes a string, which is the trigger name, and it also takes the map object, which is the trigger object itself. And that would be the load trigger consumer that we initialize with null. Then we need to go to our load map objects method. There we add a new branch here. So if trigger is equal to our layer name. Then we call the load trigger layer method. And this method here, so as before, so if the load trigger consumer is not defined, so we don't want to do anything with that, then we immediately return. And otherwise, from the layer, we get the different objects again. We iterate over all of them. All of that is already known to you. And now we simply check. So if the map object has no name or the map object name is blank, then we throw an exception because it doesn't make sense to have a trigger object without a name. Because the name, as mentioned before, is then linked to what kind of logic should be executed with the trigger. And if there is no name specified, that would mean no logic should be run. And then the trigger doesn't make sense at all. So there we say then trigger must have a name. Okay, otherwise, if the map object is an instance of a rectangle map object, that is the one that we are going to support for now, then we call our load trigger consumer and pass in the name, so the trigger name, and also the rectangle map object itself. And otherwise, we throw again an exception that this is an unsupported trigger object. Okay, and the only thing missing is the setter. So down there, we can also define now a load trigger consumer setter. Good, and the next thing would be in our game screen. So there where we register or set all these different consumers, there we also set now a load trigger consumer, which will be from our TiledAshleyConfigurator, and there on load trigger. And this is a new method that we are going to implement now. So the first argument is the trigger name, and the second argument is the trigger map object. Okay, for now we just support rectangle map objects, but in the future you might want to support here multiple different objects. So again, it's a little bit redundant here because we did that before, but for future proofness, we add here again the check for the rectangle map object. And otherwise, if it's not that, then again we throw an exception. Okay, finally, what we want to do now. So our trigger object in Tiled, we want to convert that to an entity and also create then a trigger system, which then executes the trigger logic. So as before, we need an entity. And at the end, we will add this entity to our engine. And in between, so what does this entity need? It needs a transform component. So add entity transform. There we fill in the arguments shortly. Then we need a physics component. So to get the contact events and know when the player is colliding or entering the trigger area. Then we're going to create a new component that will be a so-called trigger component, and another new component, which is a tiled component, to have some functionality then available to identify or get an entity in our engine via its tiled ID. And why do we need that? So when we go to the objects and go to our, to the trap here, then you see this trap here has the ID 27. And when we execute our trigger, we want to get the entity which is linked to this ID 27 and then play its idle animation so that we see the spikes of that map object. And yeah, the way we solve that is that simply we give such entities a tiled component, and with the tiled component, we can then add this ID information and then later on get entities via the tiled ID here. This is what we are going to implement. Okay, so transform. For that one, we need the rectangle of the rectangle map object. So the transform method needs from the rectangle the X information, it needs the Y information. The set value for a trigger doesn't really matter, so it's simply 0. Then we pass in the width and the height of the rectangle. have no scaling here, so that is simply 1 and 1. And finally, we pass in the entity, and there is 1 comma too much, should be like this. Perfect. Then the next thing would be our physics component. So there we need to pass in the map object. Then the body type, which would be a static body. Then finally, the relative to information. Do we already have the temporary vector here or something? Doesn't seem like it, so maybe we need to create that. So let me write here for the moment temp vector 2, and finally the entity. And yeah, finally it's easier for me to explain now this relative to position, because now I finally have a good example to show you that. So before, when we had for example, the player. The player is linked to a tile, and also it is this object on the map. And the player object itself has a position like 9 and 231 in that case. And then the tiles of the player, they are relative to 0, 0. So they are located here. So if this rectangle here, which has the position 0, 0, if we now want to place that here correctly, we need the player position, and then exactly at the player location, we need the fixture as well. So this is how that works. But when we have just a map object without a tile, so this trigger object, then we already have the X and Y position again of the trigger. So it's just some arbitrary coordinates. And the map object itself, so the fixture that we are going to parse now, also has these values because it's the same rectangle. There is no additional tile and a tile with some objects. It's just that single object here. And with our parsing logic, we would then add this X and Y value again to the fixture. And the body position of the trigger would be then correctly here, but the fixture would be then something up here because we add X and Y 2 times. And to avoid that, I introduced this relative position. So for a normal object, it's always 0, 0. So that's why we end up correctly with our fixtures here. And for map objects without a tile, the relative position is the object position. And then we simply, from the different fixture, we then subtract that again, or subtract that. So we end up again with a X value of 0 and a Y value of 0 for the fixture itself. And then it's correctly positioned here. So that's why we need this relative information here. And yeah, again, so what we need here for now a temporary vector 2 again. Okay, and in our load trigger method, there we now set this temporary vector 2 to the X coordinate and Y coordinate of the object. And additionally, we need to scale it with our unit scale. And let's put that in separate lines to make it easier to read. Good, so that problem is already solved. Now, another minor problem that we have is that our initial method takes a map object, so a list of objects for the fixture creation, but we only have here one specific fixture, so one specific map object and not this list. So let's simply create a new method up here, which just takes the single map object, the body type, the relative position, and the entity. And now again, we need some temporary object to not create that all the time again and again, which will be map objects instance. Okay. And up here, so if from our temporary map objects, the count is greater 0, so it was used already somewhere before, then we need to remove the object that was added before. So this single map object that will be added there. And after that, we can then add this single object to our temporary map objects list and call our previous method again. With the temporary map objects, the body type, the relative position, and the entity. Good, good. So the only thing missing is now the trigger and the tiled component. So let's create that as well. The The first one will be the trigger component, which simply has a name and a link to the entity that is triggering the trigger entity. So it will be like this. So we have the trigger component, we have the mapper, we have the name of the trigger, and we also want to know what kind of entity is then triggering the trigger. So which entity is entering the trigger area. In our case, it will always be the player. And to have a link to that, we have here the entity linkage and call that triggering entity. And yeah, when we create the trigger component, we pass in the name. The triggering entity initially is always null. We have a getter for the name and a setter and a getter for the triggering entity. And that's it. And the last component now is the tiled component. And this one is also rather simple. So it's again a component with a mapper. It has an ID. So that is the map object ID. In our case, it will be this 27 that we saw before. I think this is it's a little bit confusing because they are overlapping. But this one here is the 27 ID. This will be an ID of our tiled component. And the trap here has the ID 26. Okay, and otherwise, if needed in the future, we also have a reference to the entire map object, not just the ID, and then we can extract certain properties or other information if necessary. That's it. So coming back now to our configurator class. Now in the trigger component, we need to provide the trigger name, and in the tiled component, there we pass in our rectangle map object, and inside here, there we extract the ID with getPropertiesID. Good. We also need this tiled component on our normal objects so that we can then get the trap object and adjust the animation. So in our onload object method here, there we're going to add a new tiled component. And again, we pass in the tiled map object here. Perfect. So if we load our game, we should now see some Box2D picture already around our trap. Let's see. Yep, that looks good. So maybe in the video it's not visible, but I see here a green border around the trap. The sensor is also working, so I can walk over the trap. The set index is also working. The trap is always in the background and is never in the foreground of the player. So that looks already quite promising. So there are only two more things missing. Then we are finished with our trigger system, which is great. So we need to implement a trigger system, which has access to our audio service and implements the process entity, and it's iterating over any entity which has a trigger component. So that's it. The approach that we have here is a very, very simple approach. So the trigger logic will be inside the trigger system. And also there are no conditions for a trigger or anything special. So this will not scale very well if your game gets bigger. What I used in Masamune is that I had a separate trigger configurator class, which created so-called trigger script objects. And the trigger script was nothing else than a list of actions that get executed similar to the scene2D action sequence, like moving a character from A to B, applying damage, playing an animation. So there are a lot of different actions available, and the trigger is simply a sequence of all these actions. And the trigger system then simply has a list of the currently active triggers and calls the update function on each of the trigger actions and progresses the trigger script objects. And once all actions are done, then the script gets removed and cleaned up. And this is what I implemented. But that is a more complex approach. And again, I think that is for each individual game, you most likely want to implement it differently and don't just want to follow my specific approach. So that's why here we follow a very, very simple approach. Everything is directly inside the trigger system, but should get you started with triggers and scripting in that specific case. And you can adjust it then to your needs. So the logic. So first of all, from our trigger component, we get the triggering entity. And if it is null, then we don't want to do anything because our trigger wants to react to events when another entity is entering. So when the player enters the trap. Then down here, we know that there is a triggering entity. So we will fire the trigger here. And here we pass in the trigger name. And we also pass in the triggering entity. And finally, from the trigger component, we clear the triggering entity again because the trigger is then executed, and we reset it so that it's not executed again and again. Good, then the fire method. So the first argument is the trigger name, and the second one is the triggering entity. And here it's just one trigger, but yeah, let's use a switch statement here. So if it is our trap trigger, and again, this name here, trap trigger, is linked to the object name here in tiled, which is also trap trigger. And when we do that, then we want to, let's call that execute trap script, for example. And there we just pass in the triggering entity. And otherwise, we can throw, sorry, wrong syntax here. We need the arrow. Otherwise, we can throw a new GDX runtime exception again and say unsupported trigger. So there is nothing implemented yet, and provides the trigger name, which is missing. Okay, then trap trigger. What should happen here? So first of all, we want to get this trap entity, so the object, and we want to play the idle animation. And additionally, we want to play a sound effect. And damaging the player and so on, as mentioned, we skip that. We don't do that here in that example. So we need a method get by tiled ID or entity by tiled ID. And the ID that we need is, what was it? 27, I think. So let me go to the layers, to the objects. Then we have the objects layer, and the trap here has 27. Okay. And this method will return an entity, and we call it trap entity. So if the trap entity is null, so if it's not found, we can return. Shouldn't happen, but maybe it's not even a mistake. Maybe the trap gets cleaned up or something else with some magic of the player or disabled. So yeah, simply we don't do anything if we don't find that specific entity. And otherwise, we get the animation component. Then we set the animation speed to 1, which is initially the object is configured with a speed of 0. So that's why nothing is played. Then we change the play mode to normal so that the idle animation is played once. Then we also play a specific sound effect. So we just have the swing sound effects. In the repository, I also had a trap sound effect, but for now we just play this swing sound effect. It doesn't really matter. And finally, so there is a special class in LibGDX which could be useful for you from time to time. It's called timer, and there you can schedule a specific logic. And what we do, we create here a new timer task, and we override here the run method. And what we want to do, we want to run this logic after a specific delay in seconds, which would be 2.5 seconds. So this schedule function here for the timer has a couple of methods. So you can execute a specific task after a specific delay in seconds. You can execute it periodically with a specific interval, and you can execute it a certain amount of times with a specific interval and a specific delay. And the logic that should be executed is implemented inside the timer task run method here. And what we want to do here, so after that, after those 2.5 seconds, we reset the animation speed to 0, and also we set the type of the animation to idle. So we don't really change it, but this set type sets this dirty flag. And with that, the animation gets restarted, and we are back to the original animation of our trap. So the timer schedule functionality here can be useful to delay certain things or execute things in parallel. Good, then the only thing missing now is this entity by tiled ID. So there we pass in the tiled ID. And what we need, so from our engine, we want to get all entities of a specific family, and the family that we are interested in is the tiled class component. So all entities that have a tiled component. And then we simply iterate over all these entities. We get their tiled component and check if the ID is equal to the tiled ID that we passed in. If that's the case, then we have found the entity and we can return it. And otherwise we didn't find it, then we return null. Okay, and I just see here the triggering entity is not used. That would be our player. And in the repository, there I apply some damage to this triggering entity, so it is used. But since we don't do that here, it's unused. But you get the idea. So the triggering entity is our player entity. We get the trap, we play some animation and sound effect, and additionally, we would damage the player. That was the idea of this trap example. Yeah, that's it with the triggering system. So let's add that to our game screen. For example, after the animation system, there we add our trigger system. Good, and finally, so currently we never set the triggering entity and we don't react or check anything that the player gets in contact with the trap. And that is now, in my opinion, the important part of this video here. There we are going to adjust our existing physics system and we make it a contact listener. So a contact listener is a box2D class, and it simply provides certain methods for body contact. So when bodies are colliding in the physics world, and then you can do certain things. So first of all, what we need to do, we need to set the contact listener of our world. That would be our physics system. And also we need to override a couple of methods. There are in total 4 methods. It's those 4 here. So begin contact, end contact, preSolve, and postSolve. And what are they doing? So when 2 fixtures, it's actually fixtures which get in contact with each other, then first of all, the preSolve method is called. And in this preSolve method, you can, for example, control via the contact object that gets passed in here. You can enable if the contact is enabled or not. So if we say here contact set enabled false, that would mean that all our collisions are not really happening and bodies can simply move through each other. So there is no solving of the collision happening via box2D. The default value is true, but you can override that here with your own custom logic if you want to deactivate a specific collision between objects. Then there is the postSolve. So after the collision is resolved, so that the 2 bodies are not inside again, then there is the postSolve method, which is called then afterwards. And additionally, you have a begin contact and end contact. So that is simply when 2 fixtures get in contact with each other, then begin contact is called. And when the collision is resolved, so when they are no longer in contact anymore, then this end contact method is called. And what is important, inside these methods here, do not add or remove physics bodies because then your simulation will simply crash. So that is not allowed. If you, for example, maybe you get in contact with a death trap and you want to kill the player immediately, then you cannot do that inside that method. You need to delay that. Can be solved very, very simple by, for example, add a death component or something, or a delayed removal component to an entity, and then implement a removal system, which then cleans up the entity and the body later on. But important is don't remove bodies inside these methods here, because then your game will crash, because that is not supported by box2D. Okay, and the only important method for us is the begin contact method. We don't need to implement anything here. I show you something in the preSolve method regarding the contact set enabled that you see how that is working or what it does. But for us important is the begin contact method here. And a contact, as mentioned, is always a contact between 2 fixtures. So what we can get here, we can get the fixture A and we can get the fixture B. Then, as we know, a fixture is always linked to a physics body. So we can also get from our fixture A the body. And also from our fixture B, we can also get the body. And from that body, we can get the user data, which could be, depending on the physical object, it could be an entity, but it could be also something else. So for example, for our environment physics bodies, there the user data is simply a string of type environment or with the content environment. But for game object bodies, there it will be an entity. And yeah, what we can then do here, so if the user data, oh, I called it entity A, sorry, that would be user data A. And below here, that would be user data B. So if our user data A is not an entity, or our user data B is not an entity, then we can return, because we are only interested in entity contact. So when our player gets in contact with the trap entity. So those are the collisions that we are interested in. And the other collisions, which are not between two entity bodies, there we simply don't do anything and we simply return here. Also, A and B, there is no sorting. So you cannot know for sure that fixture A is always the player and fixture B is always the trap. From what I know, it's simply the time when bodies are created. So if your player is created first and the trap afterwards, then when they get in contact, the player is the first fixture and the trap is the second fixture. But again, that is not guaranteed and really depends on the timing from what I know. So that's why the code, I haven't found a good strategy here, but that's why the code is a little bit redundant. You always need to do the thing with A first and B, and then swap it around with B first and A first. So here we are going to implement a new method. Let's call that player trigger contact. We pass in entity A, we pass in the fixture A, and we pass in entity B and the fixture B. Okay, and we want to get the trigger component here from entity A. And then we want to know if our second entity is the player entity. And there we are currently missing something because we did not need it yet and did not introduce it yet. But we need a third component actually, which is called the player component. So again, it's a very, very simple component like a tag where we want to identify if an entity is a player. So it just has the mapper. And how does it work? So in our TiledAshleyConfigurator, we have our load objects. And there we also create a new method here. Let's call that add entity player, where we pass in the tilemap object and the entity. And finally, from that object, we check if the name is equal to player. And if it is like that, then we're going to add the player component to it. And in tiled, so our player here below, that one has the name player, so it will receive the player component. Good, and so now here we can use our player mapper for entity B and can simply check if it has that component. So if it is the player, that's already sufficient. And also, if it is entity B, then fixture B must not be a sensor, because we only want to react when the real player, so when it's a real fixture which has a collision, when that one gets in contact with the trap, and not when the other fixtures, like all these attack sensors, which are way bigger than the player itself, they should not trigger the trap. The trap should only get triggered when the circle shape below the player, when that one gets in contact with the trap. So that's why we also make here the check that the fixture is not a sensor. And finally, so if there is a trigger component and we have the player, then from this trigger component, we can set the triggering entity, which would be entity B in that case, and we are done. And now could be written a little bit better with a separate method maybe, but now we need exactly the same logic, but we need to swap around entity B and A. So here we have entity B, here we have entity A and fixture A, and we pass in here entity A. That's it, because it could be, again, that fixture A is the trap and fixture B is related to the player, but it could be the other way around. So that's why same logic, but B and A swapped. Could be written better with a separate method and yeah, then just swap the arguments when they are called, something like that. Good. I think theoretically that should be it. Let me think that through. So we have our physics system that was already added before. We have a new trigger system. We are now getting here contact events because we set the physics system as a contact listener. We set then the trigger system, the triggering entity, which ends up in our trigger system. And there we should then execute a specific logic. So yeah, let's see if that is working. Looks good. Looks perfect. So yeah, when we get in contact with the trap, so again, the fixtures do not trigger the contact event. It's really just the player circle here. Then this animation is played once, and with our timer, after 2.5 seconds, we reset the animation and the trap is back to the original state. And yeah, as long as we are inside the trap, it's not getting triggered again because we are still in contact. So the begin contact was called, but the end contact method was never called. When we leave, now end contact was called. And when we get in contact again, begin is called again, and we can re-trigger the trap again and again. Perfect. Yeah, so the last thing that I want to show is this preSolve. So there, as mentioned, we could, for example, set here very simple contact set enabled to false. What does that mean? So now we can walk through everything again. So there is no collision between our trees, no collision between any objects at all, because the contact is always not enabled. The events with begin and end contact, they are still fired. So Box2D still knows when something gets in contact or when the contact ends, but the collision handling or the solving of the collision is disabled when we say contact set enabled false. And yeah, let me turn off the music. That could be useful in certain games where you maybe don't want a specific collision happening between specific object types. There would be something else in Box2D. I haven't covered that in this tutorial because I personally don't like it a lot. But a physics body, or is it it's a fixture, can have so-called filter data, and you can work them with bit masks and things like that, up to 16 or 256 different bit masks, I cannot remember, where you can then very fast tell if two objects should collide or not. So this is the built-in functionality of Box2D, where you need to work with bit masks. And I personally don't like that a lot because it's, in my opinion, not so easy to read the code and understand what is happening. So that's why I personally always use the preSolve function here below. And there, similar to the begin contact, I can get the fixtures, the entities, check for specific states of my game, and then tell Box2D if collision resolving should happen or not. It's of course slower than the bit mask handling, which is built into Box2D, but in my opinion, it's easier to read and understand, and also allows way more possibilities than just working with the bit masks. But that's it, guys. So that was the entire tutorial series and everything that I wanted to show you. I hope you liked it. For me, it was a lot of fun to develop the tutorial. That was unfortunately already, I think, 3 or 4 months ago. Then I didn't have time to record anything. So going through the codes was not so easy anymore because I couldn't remember everything that I did and why I did it. But yeah, I hope you learned something from it. I hope actually you learned a lot from it. You had some fun. And yeah, wish you the best with your future games. Thanks for watching and bye-bye.